Hello guys and welcome back to the channel. Today I have a very special video for you guys. I'm going to show you how to create React Native C++ turbo modules. And the reason why it is special is because I do not believe there is any tutorial online that shows you how to create that because it's super new, right? Like it's very fresh. There's barely there's no documentation kind of on how to like do it properly. It's all in pull requests and GitHub yeah, PRs and discussions, right? And so the idea behind C++ turbo modules is you would generate a spec, or like you would define a spec, right? And from this spec, you would have a C++ class that's generated for you, implementing like defining your functions, and then you would have to implement them basically. And the nice thing about this is that you get type safety, and also you do not have to define like Objective-C for iOS and Java or Kotlin for Android parts that you would have to invoke first. Like you don't have to go JS, iOS, and then C++, or like for Android. No, you go directly um, JS to C++, right? So the code is way less than, for example, the video that I've showed you, the previous two videos. So yeah, it's very exciting, guys, pretty new, and I hope you guys enjoy it. In this video, I'm going to show you how to do it for iOS, and in the next video, I'm going to show you how to do it for Android, right, guys? So let's get started, and as always, I'm going to be using the Create React Native library. So npx create React Native library. I'm naming my library React Native CPP Turbo. You can name it whatever you want. Let's hit enter. It'll ask us a couple of stuff. The name of the package, keep it the same. Description, C++ Turbo module. The name of the package author, me. My email address, my GitHub for URL for the repo. Now here, we're going to pick Turbo module. In the previous videos, we were doing also backward compatibility. Now, because we are using CodeGen here, and CodeGen is only available on the new architecture, then we will only be picking Turbo module. I believe that's fine because, I mean, with time, there's only going to be new architecture. It's not like you choose one or two, right? Like it's not either this or the other one. In the future, it's only going to be the new architecture. That's what's expected from everyone. So let's go ahead and pick Turbo module here, and then C++ for Android and iOS. Finally, pick vanilla. And what I want to say here is that I want to make it clear that even though we're picking Turbo module in C++, the implementation of this like generated template won't be what we want, because the way that they do it is kind of the old way, where you'd have to kind of pass through the platform. For example, JavaScript would invoke an Objective-C function, Objective-C would invoke a C++ function, right? And same thing for Android. But we don't want to do that. We want to go direct to CPP, guys. No jokes here, okay? So let's go and cd into the library, and we need to run yarn to um, install the dependencies, right? Cool, guys. Now that this is done, let's go ahead and check out the project. This is the structure of our module. The important part for us now is the source directory, and in here there's a file that starts with native. The other part, CPP Turbo, depends on the name of the module that you created. For me, it's native CPP Turbo. And in here, go inside it, and what's important for us is this spec, right? So with the new architecture and Turbo modules, you'd have a spec that you would define the modules that you want to expose, and there's something called CodeGen that would use that as the source of truth and generate C++ class, or for Android, an abstract Android like Java class, or for Kotlin, and same thing for Objective-C and Swift. But in our case, we're going to be only using C++, and this is used as the source of truth for. So the functions that we're going to implement here, let me search snippets. Yeah. So we're going to implement, guys, 5 functions. If you've seen my 4 previous videos, like I've kind of went through like gradually through different levels. First I explained Turbo modules, then JSI, C++ modules, and now I'm explaining CPP Turbo modules. But throughout the entire, like all of the videos, I'm kind of implementing the same functions just to kind of make it easier to follow and just explain the general concepts. Like the concepts not really like the functions themselves, right? So, but still, I'm going to I'm explaining to you how to do like different stuff, right? So there are 5 functions, and the first one takes in a string, reverses it. The second one returns an array of numbers. So I show you how to return arrays. The third one, we return an object. That's very useful and handy if you want to return an object from your library. Fourth one is a promise, because sometimes you want to do async and await, because sometimes things take time. So in our example, we're going to take in a number and resolve that number in a promise. Pretty simple, but you get the idea. Now you know how to do promises. Fourth one, you take in callbacks, also pretty useful. Sometimes you want to do something that takes in some time, could succeed, could fail. Want to take in a success callback, failure callback. So I also show you how to manage callbacks. So perfect, guys. We just defined our spec with 5 functions. CodeGen will be using that to generate our C++ class. Perfect. Let's go ahead and let's go ahead and check out this iOS directory. So as I said, we won't really have like iOS classes that export our module. Like for example, if we take a look at this there's this RCT export module, and then there's this multiply that calls the CPP multiply. We don't really care about that, guys. So just go ahead and delete that. And this one, instead, we're going to have a class called onload.mm, right? We're going to be using this one later, but just add it for now, right? It's just one class, and that's going to help us register our C++ module, right? So that it auto links. But just add it for now, and we'll edit it later. And then for the CPP directory, that's where we will have our logic, basically. So we're going to have our custom ones. So just go ahead and delete these two, right? And the one that we want, we're going to be naming it native CPP turbo module.h. I'm going to copy this one and have it be CPP, right? So usually in C++ you have a header file and this CPP file. One contains kind of like the definition, and the other one is like the implementation, right? Pretty similar to Objective-C if you've used that before. Now that we've defined our files, guys, let's go ahead and run pod install, right? So when you are like developing an iOS project, you would run pod install in the example project. And so just so that you guys know, when we generated this module, it created an example module, example directory for us, and this contains an Android project. All right, so we're going to go into this example directory, which contains a React Native project, and run pod install, which is going to just basically install our module for us, right? So let's go into example and run npx pod install. All right, guys, now that pod install is done, we will now want to write our module, right? We want to implement the functions that we specified in the spec. And in order to write the module, I'll be using Xcode. I believe you need to always use the right tool for the right thing. And I think if you want to develop like the iOS part of things, it's best to use Xcode. So inside the example directory, go ahead and either run xzd iOS. If this does not work with you, you can just open up. Let me check here. Just go to whatever place you have the project, go to the example directory, iOS, and open xc workspace, right? So this does the same thing. This opens up the workspace. I like to use it from the command line. Now that we run pod install, we should be able to see our module inside pods, development pods, and it should be here with the same name as the module. So I named it React Native CPP Turbo, so that's where it is. Now go ahead and expand the CPP directory, and let's first edit the header file, right? So in here in the header file, we want to kind of declare our class that we will later write the implementation for. All right, so let me go ahead and add that. Yeah. So As you can see here, guys, we are including React codegen /rn cpp turbospec jsi.h. Now you might be wondering, where is this file coming from? Like, we did not write this one. True, we did not write it, but it was generated for us, right? And how do I know the name of the file? It's because when the project was generated for us, let's go ahead and first go one fold directly before, open up. So in the package.json, there is something called codegen config, right? In this codegen config, there's a name, all right? And the name for us was set to rn cpp turbo spec. And that's because we entered the module to be React Native CPP Turbo. So it added this rn cpp turbo. And by default, like, or like the convention is to add spec at the end, all right? So this file was generated through codegen, right? It took this name and added this JSI to the end. And if you'd like to inspect it, you can go to React codegen, and then you'll see that this file was indeed generated for us, right? So there it is. Cool, guys, we are importing this, and now we are defining a class called native CPP turbo module, which is the same like name as the file name. And we are defining that inside a namespace called Facebook React. All right, guys. And this class is inheriting publicly from native CPP turbo C++ spec. All right. And it accepts a template parameter, and we pass just the same name as the class that we defined here. Now you might be also wondering, okay, where is this class coming from? Again, codegen. That's the entire idea of codegen. It's like it does stuff for you, so you don't have to do it yourself. All right. So inside this auto-generated file, there is this native C++. Let me check. Yeah, native C++ native CPP turbo, which is this one. Native CPP turbo C++ spec. So this was generated for us, and we are inheriting from it. All right. And we are adding one constructor. All right. So a constructor is like pretty similar to a JavaScript class constructor, which is just a function that creates an instance of the class, right? And we are just saying that for the constructor, we expect one argument, which is a shared pointer, and we are naming it JS invoker. We have no implementation here. We're just defining definitions, guys. All right. Now, one more thing that we need to define now are the functions. All right. Now, in order to define the functions, we can literally just copy them from here. You see, these functions, reverse string, get numbers, get object, promise number, commutator, these are C++ code that was generated for us, again, from codegen. So we have these native CP turbo. Again, we already said that, like we had these, and this was generated for us. So let's go ahead and copy these, guys. And pop. You just need to remove the virtual, okay? And also just delete the equals 0. All right. All right, so now we are just saying, all right, we have 5 functions, and all of them, it's like all of them receive the first argument, the JSI runtime, right? This is like, you could think of it as the like runtime, which we can access from it, the global JavaScript object. Like this is kind of the JavaScript runtime, all right? And this is always the first argument, and then the second argument is like second, third, fourth, whatever, are the arguments that you were expecting from the function. So reverse string was expecting a string. First you get the runtime, then the string. Get numbers was expecting nothing as the argument, then you only get the runtime, all right? And the same for every other function, right? And the return values also like respect the return values that you set. That's good, guys. Now let's go out to the CPP, right? Let's close this one. And now let's go to the C++ file, and that's where we define the implementation for these, for the constructor and the methods, right? So let's go ahead and do that. snippets sn3. Yep. All right. So guys, we're just here including the header file. Like when you want to add implementation for a file, you need to import, or like for a class, you need to import that class first. So we import this native CP Turbo module here, right? And then to like define constructors and functions, we set up the same namespace, right? Like Facebook React. And then in here, we are saying for this class, native CP Turbo module, which is this one, right? We want to define the constructor, which has the same name, which takes in the JS invoker. And for the implementation, what we want to do is we want to call the superclass, right? Because here we are inheriting from this native CP Turbo C++ spec. You only need to kind of call the superclass and move the JS invoker, all right? So this is pretty like, how can I say, you don't really have to understand much here. It's always kind of the same thing, right? You just call the superclass, you pass it the JS invoker, you move it there, all right? What's interesting for us is the implementation. So let's go ahead and implement the reverse string, for example, all right? So snippets for, right, up, and actually, so the snippet does not include the function itself. Let's go ahead and copy that. I'll explain it in a minute. Let me copy. All right, guys. So here we are defining this class has this method that takes in the runtime and the string. And in order to reverse it, first we need to change this JSI string to a C++ string. And the way you do it is you do str.utf8 and you pass it the runtime. It expects the runtime as an argument. Now it's just C++. You reverse it by calling std reverse. You pass it the beginning and the end of the string. And then because this expects to return a JSI string, the way you would convert a JSI string to a C++ string to a JSI string is by saying JSI string create from UTF-8, you pass it the runtime, and then you pass it the C++ string. All right, so now that's reverse string done. Let's go ahead and implement get numbers. So we copy this one, this, just you need to prefix the method with the name of the class. Boop, boop, boop. Right, just like that. And then for the implementation, let's use my snippet here, snippet, and that would be snippet 5. All right, so what we're doing here, we're expecting no arguments. We are just creating a JSI array. There's a type provided by JSI, which is an array. And then you create an array, you pass, it expects the runtime, and then the number of elements. We want 10 elements because the way that I'm just, as an example, I'm going to return an array of 10 elements from 0 to 9, right? And then I create a loop that goes from 0 to 10, non-inclusive. And then I take this array and I invoke the method which is set value at index, which given an index and a value sets that value at an index. Always that it expects the runtime as the first argument. So something that you're going to see is that most JSI functions expect the runtime as the first argument. All right, so this is pretty repetitive. So it expects the runtime, expects the index, and then the value, right? Now, because the index is of type size t, and we want an integer, so we cast the index to an integer, and then we pass, like, we create a JSI value, right? Because what you pass to the JSI array are usually JSI values, right? And to convert an integer to a JSI value, we would create it this way, all right? Finally, we are returning the array. By the way, one thing that I want to kind of let you know is that in the previous 2 videos, we've actually also went through the same thing, and I'll kind of do a comparison in the end of the amount of code written in the previous video and in the current video, and you'll see like how it's way easier here. Finally, now let's do a get object. Let's copy this one, right? And then let's copy the name of the class, right? Let's implement this one, snippets, and this one was snippet 6, right? So again, we're creating a JSI object, passing it the runtime, and then you set the property this way, pass the runtime, you set the key result, and with the value of success, right? And as again, when you want to create a JSI string, you would do JSI string, create from UTF-8, just like we did here. You pass the runtime and then the C++ string. Now you return the object. Easy. Let's go ahead and do promise number. Promise number. Let's copy this one, the name of the class. And actually, so because the snippet I have expects this one to be number, I believe. So let's change this to number. And now let's do snippets. And this was snippet 7. All right. Let me maximize here my one. Yep. So the way that you would do promises is you get the promise constructor from the runtime, right? So runtime is the JavaScript runtime. From there, we get the global object, and then we get property as function. So we get this property, which is the promise, we get it as a function, right? And then we call the constructor of the promise, passing it the runtime. And if you know, like promises, the constructor of the promise takes in a function with 2 arguments, which is the resolve and the reject function. So that's what we're doing here. All right. That's how you create a function in JSI. You pass it the runtime, you pass it a name, doesn't really matter here. I'm just saying promise arg because this function is the argument to the promise. I say you need that it requires 2 arguments, shall resolve and reject functions, and then here you define the function, right? You get past the runtime, you get this value that's in JavaScript, and then here you get past the arguments. The arguments are again the resolve and reject, and then you get the number of count, which is the number of arguments. Finally, what we do here is we get the resolve function, which is the first argument, and then we cast it as an object, as a function, and then finally we just resolve the number that was passed in, right? We passed in the runtime, we passed in the number is the one that's passed in, and then because we need to return something, we return undefined. All right, so that's how we would do promises. Again, I explained this in my previous videos, so this is kind of more of a just a quick refresher, right? Finally, let's do the cumulator. Let's go ahead and copy it. Yeah, and let's add in the name of the class, clipboard history. Yeah, cool. And that was snippet 8, right? So again, cumulator accepts the runtime always as the first argument, and 2 functions, success callback, failure callback. And what I'm doing here is basically just getting a random boolean by calling stdrand and doing a modulo, the modulo operator with 2, which returns either 0 or 1, and then this is casted as a boolean, so it's true or false. If it's true, I'm calling the success callback. If it's false, I'm calling the failure callback, right? And the way that you would invoke a callback or a function is by just calling the invoking the .call method. So success callback.call, and you pass in the runtime. Nice, guys. So now that we implemented all of the functions, let's go ahead and check this onload that we created. Okay, that's interesting. So I just want to kind of let you guys know here that that's where the magic is happening, right? So, all right, we created the C++ class, we added the implementation, but how will it be like linked, right? Like how will it be registered, right? And that's how we're going to register it. So let me add in the code, and then I'm going to explain it to you guys. Yeah. So we are basically creating a class called onload, right? Which inherits from NS object, I believe. And then the implementation for this onload, we're only adding one static method, which is a load method, right? And in this load method, we are calling a function called register C++ module to global module map, all right? So where is this function coming? This is coming from React. So there's a header file called C++ turbo module utils, right? And inside that header file, there's this function. Basically, what this does is you pass in two arguments. So here we are passing this first argument and this second argument. So it takes in two arguments. The first one is the name of the module, and the second one is a lambda function or an anonymous function for like JavaScript developers that would return an instance of this for what was it called, for example, for the module, let's say, right? So the name of the module here that we are passing is a C++ string of Facebook React Native CP Turbo module K module name. Now you might be wondering that this is the same name of the C++ class that we created, right? Like this one, we created this one, but we did not add a K module name. Where did this come from? Well, CodeGen, right? We said that this one is inheriting from this class. Now, if we check out this class, you'd see that it has defined inside it K module name equals CPP turbo, right? So where is this coming from, right? Like, how does it know that it's called CPP turbo and not something else? CodeGen. So, right, in this file, there's the CPP turbo, and that's what's used to name the module. All right, so we are saying for a module of the name of this, our module, here's the function that you need to create an instance of that module. And in this function, you get past the JS invoker, right? And all we're doing is we are returning an instance of our CPP turbo module class wrapped in a I think that's a shared pointer, right? So std make shared, and then you pass it the JS invoker, right? Because our class expects a JS invoker as part of its constructor. Now, the other interesting part is that, all right, are we going to call this load method somewhere? Like, are we going to instantiate this onload class somewhere? Actually, this is a static method. You don't need to instantiate an instance. But are we going to like call this method somewhere, or how will this be loaded? Well, here's the interesting part. In Objective-C, the load static method on a class is called automatically when the class is loaded to the Objective-C runtime. Let's check out the Apple docs. Load Objective-C runtime invoked whenever a class or category is added to the Objective-C runtime. Implement this method to perform class-specific behavior upon loading, right? So we don't have to call it anywhere. It will be called for us automatically, guys. All right. So we're actually done with our module. Let's go to our example app and test it out. So we're going to go to the example source app.tsx. Here, there's the old code that has the multiply function that was part of of this module that was when it was generated. Let's go ahead and replace that with our code, and that would be 10 snippets sn10. Right, now let me just quickly here scroll so you guys can see. I'm going to slowly scroll, so if you want to copy or like you are following along, right? So what we're doing is we're just importing some stuff from React Native. We are importing our functions, and then we are adding a function for every method just to test it out, right? So for example, reverse string takes in a string which is also reverse string, and we want to reverse it. And then there's get numbers. We're console logging the return value. We are expecting an array from 0 to 9. And also there's get object. We're just expecting to have an object of key result and value success. The reason is, if you remember, that's what we mentioned here, right? Result, success, you can add in whatever you want. Next, we are going to be testing the promise number, right? Doing async and await. We send in 5, we expect to get 5, and then we just console log promised value as we expect to see here 5. Finally, we are calling call me later, which takes in 2 callbacks. And as we said, like we saw from the implementation, it's going to call one or the other depending on a Boolean. Nice. Now, one more thing we need to fix is that here it says that these are not defined, they are not exported from the module. Let's go ahead and check our source. Here in index.ts, it's still exporting the multiply function. So let's go ahead and change that. So what I'm doing here is I am importing my module, my native module from this file, native CP turbo, right? Because we are exporting it as default. Next, let me go back here. Next, I'm just exporting all of the functions, get object, get numbers, call me later, promise number, reverse string. Now that we exported these, now let's go ahead. Now there's no longer any errors here. So now that everything's good, let's go ahead and run our app, guys, and see if our work is all good, right? So, desktop, React Native. Yeah, let's go to the example, yarn start, and npx React Native latest run iOS. I'm passing the UDID of the device, hit enter. All right, guys, seems like the app is successfully built. Let's go ahead and check if our module works, right? Reverse string, nice, it's reversed. The numbers 0 to 9, get object, cool, promised value, we're successful, and then we can call this and it should be random, calling success or failure. Nice, guys, so we just implemented it, cool. Now, one more thing I would like to add, guys, is I would like to compare the difference between the work that we've done in this tutorial and the work that we've done in the 2 previous ones, right? Now, I just want to make it clear that the 2 previous videos is how most libraries are doing it currently in production, because this is very new, right? The ability to kind of load this or register this module for like library use, like the users of the library. This is new. I believe this function, register C++ module to global module map, was not available before. So this is very new. So start like library developers will probably start to implement it this way. But I would like to compare just the difference between the code that we've written here and what we've written in the previous 2 videos, which is what's used in production, right? So here's the repo from my previous tutorial. Let's go ahead and check the reverse string function. Let's me put these side by side. Okay, so guys, that's reverse string in the new implementation, and that's reverse string in the old implementation, right? Like we had to define our JSI function, define how many arguments it takes. One, we had to make sure, because JavaScript is a like dynamic language, even if you say you need 1 argument, it could pass 0, 1, 5, 10, who cares, right? So we had to do some error handling. We need to check that count is 1, and we need to check that the argument is a string, otherwise we throw an error. And then we had to, because arguments by default are just JSI value, it's a very generic type, we had to check that like cast the argument 0 to a string, like as string, and then do UTF-8. Here we just expect a JSI string and we just directly do UTF-8, right? For example, the promise, right? Like this is long, but if you would see the promise here, I mean, that was all the just the promise, right? And also we had to create the function, add it to a custom property, and then we had to manually add this property to the global runtime, right? We were saying the JSI runtime.global.set property. So it's just way too much work that we don't really have to do, right? Because now it's way simpler with the new stuff that's happening in React Native, right? So one more thing that I'd like to add is that everything is handled for us, like also the error handling. Like here we said, oh, we need to check that we are passed one argument and that's a string. So that's all done for us, because if you check this class that we are inheriting from, you'd see that here there's this reverse string and there's expected reverse string to have two parameters. Like it's doing all of the checks for you, right? So there's so much heavy lifting that's being done for you, because it's all because of CodeGen, right? All because we are clearly defining what we're expecting our library to expose. This one, okay? And with that, we reached the end of the tutorial, guys. I really hope you guys enjoyed it, learned something new. As I said, I don't think there's any tutorial that shows you how to do that. So if you enjoyed it, please hit the like button. You know, that's how I get motivated. You know, I know that you guys are liking this, are benefiting from it, so I can do more of it, right? If you have any feedback for me, let me know if this is good or not. Please add it in the comments, let me know. And if you'd like to know when I create a new video and publish new stuff, you can subscribe to my channel. I'd be very happy, you know, see the subscriber count go up. That'd be really nice. And yeah, guys, thank you very much for watching, and see you in the Android video. I'll be implementing Android in another video, and also I will be making some improvements to this, because you can still improve the C++ Turbo module. And until next time, see you guys and bye.